Hello, my name is Eddie Haddon and I work with Gamma Graphic Services. Thank you for taking time to review our presentation on non-destructive testing. At the end of this presentation, myself and Jim Kovarek will be available to answer any questions you have relative to non-destructive testing methods or their application within the ammonia refrigeration industry. Gamma Graphic Services is a full-service non-destructive testing company specializing in ammonia refrigeration. We have been doing non-destructive testing services within the industry for the better part of the last 16 years. During that time, we have serviced facilities both internationally as well as here within the United States. Today we're going to discuss radiometric profiling and why it is the best option for the unique characteristics and challenges presented by ammonia refrigeration systems. NDT, otherwise known as non-destructive testing, uses calibrated equipment to test the health of pipe systems. Oftentimes, EPA and OSHA inspectors will recommend that NDT testing be done based on some visual inspection that has been completed. It's worth noting that inspection is usually deemed as a visible use of the naked eye to ascertain the health or the condition of the exterior parts of a system, whereby non-destructive testing again is to use calibrated equipment to test what is unseen by the naked eye. When ammonia refrigeration became regulated in the early 90s, the industry looked around to see what non-destructive testing methods were available so that they could be used within ammonia refrigeration. The most predominant methodologies used by other piping systems like petroleum, energy, chemical plants, those technologies happen to be radiography and ultrasonic thickness testing, both of which work very well in those environments. However, they do not meet all of the gaps created by the unique challenges of the way ammonia refrigeration systems are structured. Non-destructive testing, in its greatest benefit, provides a diagnostic picture of what your system is, which will then allow you to meet regulatory compliance as well as project budgets for maintenance and repairs. Non-destructive testing is the most reliable way to know the true health of your system without having to strip down the insulation and jacketing. The words non-destructive testing imply that no damage will be done to the pipe system itself. However, some technologies are not able to test the health of the pipe without damaging the insulation or jacketing. And as you know, in the ammonia industry, insulation and jacketing are very critical to maintaining thermal efficiency and protecting the underlying pipe from any corrosion. Oftentimes, facilities will employ non-destructive testing expecting that there will be no damage to their system and that there will be no disruption of workflow. When hiring any vendor, you're hoping that you're going to get unbiased results with reliable data you can count on. Unfortunately, if the wrong technology is applied, there will be damage that occurs to the pipe structure, in as much as the insulation and jacketing could end up with holes in it. And if inefficient technology is applied, not all of the pipe structure will be able to be tested. Only those areas that are most convenient can be tested by some technologies. Damage occurs to piping in an ammonia system different than it does in any other industry. The way that the piping begins to deteriorate is from corrosion under insulation, remembering that ammonia is not a corrosive agent. Therefore, in most scenarios, we're not concerned with pipe deteriorating from the inside. Oftentimes, other technologies that are used in different pipe systems, such as petroleum, energy, chemical, when those applications are done within ammonia refrigeration, if the technicians are not aware of the unique characteristics of the ammonia refrigeration system, those technicians can sometimes do more harm than good. Remember that within ammonia refrigeration, insulation is very, very critical to the overall pipe structure. If we poke holes in insulation, it becomes an entry point for moisture, which allows condensated moisture to collect around the pipe and begin to corrode the pipe, which is known as corrosion under insulation. Oftentimes, the damage that's occurring within that insulation cannot be seen until it's much too late. During the course of our 16-year history as a company, 100% of the ammonia refrigeration facilities we have been on have had hidden moisture within their insulation, whether that be water or ice. On average, 30% of piping insulation has some type of moisture hidden in it. By the time there is a visual indication of corrosion under insulation, it's likely approaching failure or at the very least in need of priority 1 maintenance. This is why 13% of ammonia leaks are due to pipe failure. It is the 3rd leading cause of leaks according to the EPA's Right to Know records. What do you want to get out of your NDT testing? Radiometric profiling is a fast, non-destructive, non-disruptive way to scan the pipe to determine wall thickness or pipe health, to identify where moisture is building up within the insulation, whether that be water or ice, and to be able to gather information on your system that can be used to verify your P&IDs and pipe schedule. Whether you're looking to comply with PSM requirements, whether you're looking to comply with RMP requirements, or whether you're looking to meet your general duty clause, radiometric profiling is the most complete and efficient way to test your pipes. This fast, non-destructive, non-disruptive real-time scanning technique locates and measures more ammonia refrigeration locations than any other single technology available. Radiometric profiling is incredibly thorough. It captures 360 degrees of the pipe at the location being scanned, not just one wall or a single spot, unlike UT or radiography or pulse steady current. Radiometric profiling tests all pipe, not just where it's convenient or easily accessible. We can reliably scan insulated and uninsulated pipe above or under deck on straight runs in congested areas such as pipe racks, suspended from a ceiling or in an interstitial space, as well as vertical pipe drops, including elbows, T's, reducers, and all piping components that you may see across the top of your roof or within valve groups. This is very unique in that no other technology allows for all of these locations to be tested. It is this thoroughness that distinguishes radiometric profiling from traditional radiography. As you can see here, we're able to get down into the congested pipe areas, whether they be overhead or at waist level. We're able to completely scan and read all of the piping that is in that area. You can see here that the radiometric profiler conveniently fits up between pipes and allows for any type of piping to be read. What you see there is a scan 360 degrees of that particular section of pipe. Radiometric profiling is safe. It is safe for any facility staff. It is 100% safe for the pipe structure as well. There is no need to set up a barricade. There is no need to be concerned about radiation hazard exposure. In fact, your staff can be present during the testing itself. There is no need to remove any insulation or poke holes in any jacketing or insulation during radiometric profiling. We can scan directly through the insulation and the jacketing to read the health of the pipe. Radiometric profiling is the most efficient technology available to non-destructive testing. For a system that's on the roof, like you see here in this image, we're able to gather up to 200 test locations per day. Because we get real-time results as we're scanning through that pipe shown to us on the handheld computer that's part of the equipment, we're able to notice any anomaly that may show up, and if there is an anomaly, we can move left to right along the pipe to gather more extensive data regarding how bad that test area is or how much of that run of piping is damaged or compromised. By comparison, ultrasonic thickness testing usually provides results between 40 and 60 locations a day. Radiography usually provides results between 20 and 30 locations a day. So as you can see, radiometric profiling is incredibly efficient with real-time results. The technicians get on site, and before they start with the radiometric profiler to do testing, they walk the system to figure out what the flow of process will be for that particular day. Think of it as charting your navigation before going on a road trip. They're going to lay out exactly the flow of work, and they're going to do a visual inspection and make notes on any type of damage they see on insulation or jacketing. They will also identify if they smell ammonia odors in that area. As you can see there, the radiometric profiler scans through the pipe, and a technician is able to see the results in real time. Radiometric profiling allows the gathering of information and applying that information in every component you see here in front of you. With one scan, we're able to identify pipe wall thickness, which will be measured in real thickness of the metal that remains. That pipe wall thickness will then be shown as a ratio or a percentage against nominal wall. So it will identify that your pipe wall has a very specific numerical value, and then it has a percentage of wall loss versus nominal wall. We're going to be able to identify if there's any water or ice that has been building up hidden within your insulation. We understand that most folks know that they can see ice in very suspect areas where it's dripping, but usually there are several dozen more locations on your system that you don't know where the water and ice is building up, which is causing the corrosion under insulation and essentially becoming a silent killer eating away at your pipe. With all the data we collect, we're able to spot check the P&IDs at every location. So for one day's worth of work, if we collect 200 spots or 200 scanned locations, we're going to be able to spot check your P&IDs with those 200 scanned locations. If we're on site for 3 days and we end up with somewhere in the neighborhood of 600 locations, we're going to be able to spot check the P&IDs with all of that data. You can see how that would scale up or down depending on how many days of work are being done. And in the midst of being able to gather all that information, we're going to be able to let you know if there's any component that we come across that does not meet ammonia refrigeration build guidelines, which essentially is to say if you have pipe that's not up to proper code and size and schedule for ammonia refrigeration code. Because radiometric profiling is able to scan through the wall without being interfered with by insulation or jacketing, we're able to also identify if there are hidden valves that have been insulated over. From time to time, we have customers ask us if we can locate welds, which are very easy. We can identify if there's a reducer to where pipe schedule reduced for a previous repair before going back up. And if there's any remaining liquid level that seems to be trapped, we're able to identify that as well. Gammographic Services provides some of the most advanced reporting available in the industry. We do not think that it's a good business practice to gather information and ask the customer to draw their own conclusions and to analyze the data. Therefore, when we're on site, we take, as I've said earlier, several hundred readings of a system. Those readings are then analyzed by our team in-house, and we group them together for you so that you can see how those readings compare to one another within a line. So if we're on a subheader, let's say, between two tie-ins, and we take 10 readings, we're going to show those readings to you in sequence of one another and how they compare to one another. Additionally, we're going to take all of the data that we collect on a system, and we're going to provide the most important parts of that data to our customers in an executive summary. This executive summary is going to include any critical areas that need to be immediately addressed as a priority 1 for pipe wall and pipe health. Secondarily, we're going to identify any type of area that we have come across that has significant moisture in the insulation, again, whether that be water or ice, so that our customers can use that data to appropriately plan and budget for future maintenance projects. Lastly, we're going to gather any variance that we have found between the real readings and what the P&IDs identify, which will allow customers to further address that and to make those corrections necessary to their P&IDs. At the conclusion of every job, we compile all this data, analyze it, sort it, and provide it in 2 reports. One is a hard copy binder that goes on the shelf in your refrigeration office. In the event that you're audited by either EPA or OSHA, it gives you a hard copy to go over with them. Secondarily, we're going to provide it in a PDF or electronic copy to you so that you can easily and readily review it anytime you need to make reference to part of your system before any type of maintenance or repairs. Once that data is collected and sorted in the report, Gamma Graphic Services schedules a call with the point of contact at the facility, and we spend time reviewing the results, giving you a high-level understanding of how to read the report, but most importantly, giving you a detailed understanding of the areas of your pipe system that need to be addressed. We want to make sure that our customers are comfortable with the data that we've collected and the application of that data. If we have customers who come to us and ask for certain thresholds to be identified for the data, we will call the data together, applying the thresholds that they have identified either for their facility or for their corporation and their corporate brand overall, and we will provide the data in the executive summary according to those parameters. In the event that a customer of ours gets audited by either EPA or OSHA, we willingly and eagerly get on the phone with the auditor to discuss the report. This happens as such. Customer calls us and says, I've got an auditor here. They're going through my non-destructive testing. I've got some questions that I would like for you to address with them. And we will get on the phone with the auditor. We'll pull up the PDF copy that we keep, and we will go through the report with the auditor to explain how the information was derived and answer any questions that auditor might have regarding non-destructive testing that Gamma Graphic Services has put forth. Essentially, post-testing, Gamma Graphic Services will be a consultant for our customer. As the industry becomes more regulated, I think we all understand that there are more eyes on our systems, and there are certain things that we have to do to become compliant with what these new guidelines and regulations are. Non-destructive testing, again, is differentiated from inspection because non-destructive testing uses calibrated equipment. With the proper non-destructive testing, you can meet your regulatory requirements, whether they be PSM, RMP, EPA, OSHA, what have you. Become compliant with the IIAR guidelines and have on-call support in the event of an audit. Because non-destructive testing is really diagnostics for your system, proper and thorough non-destructive testing will allow you to justify budgeting in the event that you need to make some replacements. It will allow you to prioritize the replacements and repairs rather than just go after gut feeling on what you think needs to happen within your system. You'll have the data to understand exactly where your weakest points are, and it will allow you to avoid spending money on unnecessary maintenance. Concrete evidence is really the key differentiator in all of these things, and non-destructive testing by Gamma Graphic Services using radiometric profiling provides the most comprehensive data and the best picture of what you can't see within your system. In ammonia refrigeration, the worst instance is an emergency repair. Typically, that indicates that something has gone awry and there has been some compromise in your system which has resulted in potential leakage, which could lead to health concerns as well as environmental concerns. If you take action early and employ non-destructive testing as part of your overall assessment of your facility, you'll be able to find where these vulnerable areas are before they identify themselves to you. Resolving the issues ahead of time is always a better way to go and a cheaper way to do it than waiting until some type of critical event has happened. As was stated earlier, because radiometric profiling gathers so much data for a day's worth of work, depending on how many days you want, you can multiply and scale it up from there. We're able to take all of that data and go through your P&IDs and identify locations that we've tested that do not match up with your P&IDs. And it's worth noting here that Gammagraphic Services, because we focus on and we have become invested in the ammonia refrigeration industry, we are very familiar with P&IDs. We understand how to read P&IDs. In fact, we can provide full-scale quotes to our customers using nothing but P&IDs. And of course, when we gather that kind of information, we're going to be able to tell you if your pipe system meets the IIAR standards for ammonia refrigeration. It's an unlikely scenario, but it has happened. And in those events, it's better to know and be ahead of it and be proactive in making those repairs instead of waiting for them to reveal themselves and potentially create chaos for you and your facility. I want to thank you for taking the time to listen a little bit about non-destructive testing, radiometric profiling, and some of the systems and offerings that Gammagraphic Services provides to the ammonia industry. We would be happy to have further discussions with any of you relative to the technology, report review, sample reports, as well as how the quoting process goes and how those results again are provided to you. At this time, I would like to open it up for any questions that you guys may have. I'm sure between myself and Jim Kovarik, we would be able to answer those for you. Thank you so much for taking the time to review this. Please let me know if there's anything we can do to help you.
Thanks so much for that very informative presentation, Eddie. Again, if you have questions for Eddie, please type them into the Q&A dialog box on your screen. And you actually did generate quite a few questions here. So let's go ahead and start with the first one. Are you there, Eddie?
I am. Can you hear me okay?
I can hear you perfectly. How often should NDT be completed, and should facilities have a baseline to determine frequency?
There are two different things to address there. Within the industry, the non-destructive testing industry overall, we believe that you should have your facility tested right about the 5-year mark. We have heard compelling arguments to go to 7 years as far as intervals go, but frequent testing, scheduled frequent testing is the best way to approach it. And so as a company, we endorse the idea of doing it every 5 years. You mentioned also baseline. I know that this is not where the question is coming from, but at some point it's wise to be able to fully identify your whole system, to get a baseline of what your system is. Think of it as a rebirth at some point in time. Most systems that operators are working on, they have inherited. And so in those systems, there is no true X date that says on this date in history, we know exactly what our pipe structure, the health of our pipe structure is. And so from a standpoint of baseline, we think that you at some point in time should create a baseline for your system so that future reports can be compared back to that.
Fantastic. How do you test the pipe without removing insulation?
I'm going to start this and then I'm going to pass it over to Jim because he'll talk a little bit about the science. But essentially, we use a radioactive source called gadolinium-153. It is a very low-level radiation source. In fact, for those of you listening, it is so low level that our technicians can fly with it on planes. That should give you some indication of the safety level of this. And with that source, it's powerful enough that it will go through the jacketing and the insulation to be able to read the pipe. And so part of the magic of this is that we calibrate to carbon steel, much like you would calibrate a UT device using a step wedge. And we calibrate for every job. So when we get on site, we're going to calibrate to that carbon steel. And essentially, we're asking the profiler at that point to look through all of the traffic that we're going to send the beam through and to just read the carbon steel when we find it. Jim, would you like to address that further?
Yeah, that's basically it. What we end up doing is using the radiation to actually map out a density profile for the pipe metal, the insulation material, and the jacketing. And then mathematically, we remove the contribution of the insulation, any wet insulation, and the jacketing, and we're left with the pipe wall.
Okay, thank you very much. It's a very thorough answer. Are there any downsides to radiometric profiling when compared to other testing methods such as ultrasound? Does Gamma Graphics perform any NDT that doesn't rely on RP?
We like to think of ourselves as a full service NDT provider. I tell folks I've been doing this with Gamma Graphics a little over 2 years. I come from a medical background where I worked in hospitals and surgery centers for a little more than 12 years. And so Gamma Graphic Services is fully capable of using technologies in conjunction with radiometric profiling. If I'm going to be honest with you folks, there is no one single non-destructive testing method that is capable of doing everything on your system. So what will often happen is that you'll have one technology doing piping and you'll have a different technology doing your vessels. Non-destructive radiometric profiling has some limitations in that the widest or the longest outer diameter, however you want to look at that, the widest outer diameter for us is 24 inches. There's some mathematical and science reasons behind us not going beyond 24 inches in outer diameter. But that 24 OD includes pipe, insulation, and jacketing. When we get into vessels, we're not capable of using the profiler on those vessels. So much like other non-destructive testing companies, we're going to use ultrasonic thickness testing to take a reading of those vessels. Jim, anything you want to add there?
No, that's it. We try to minimize the amount of insulation we remove on vessels. So we choose locations that if there were corrosion to be occurring, the highest probability areas for corrosion to occur on those vessels is where we're going to put an inspection port. That's it.
Okay, all right, great. How do you test with aluminum cover over insulating?
Much like we would with any other kind of cover. Again, remember that this is test equipment. And so as was said in the presentation, part of the way that, what we're inferring here, folks, is that IIAR 6 started to delineate inspection from testing. And so it more or less said that inspection is going to be visual and testing is going to be using calibrated devices. And so if you hang that at the front of the door and we're going to hang our streamers underneath that, what we're doing is calibrating to carbon steel. And so as Jim had said earlier, we're going to remove any kind of contribution that's not carbon steel. In one of the videos, you were able to see, we tried to get a close-up for you so that you could see the real results. We had one technician with the profiler scanning through pipe. The technician to his right had the computer readout in his hand, and he's actually able to see that mathematical profile that shows up for us, that it's really a graph that shows us the metal density. And so even in that real-time process right there, that aluminum jacketing doesn't show up. We've calibrated to carbon steel, and because of that, the gadolinium 153 beam reads right through that aluminum as if it's not there, and it's looking for that carbon steel. And so therefore it starts to graph out for us what the values of that carbon steel are.
Impressive. Does the weather, humidity, temperature, etc., affect the accuracy of the data?
Jim, this is a science question, so I will immediately defer it to you.
All right. No, it doesn't. The accuracy of the data is not affected by temperature or humidity as long as it's not, submerged. Our computer is not sealed that well, so we can work in the rain. We usually put the computer in a plastic bag when that happens, but we don't like to get it really super wet. The biggest issues are when we're in a minus 40-degree freezer, and it's not the equipment, it's our guys. That they're not as staunch as the equipment is, so they like to come out a little more frequently and warm up. before we let them back in.
Pretty good. All right, on to the next question. Does your service provide inspection ports for insulated vessels if needed, or does the facility need to make its own arrangements?
I'm going to break this question into two pieces, and I'm going to invert it. Number one, we are the service provider. We're not going to ask you to go out and measure pipe and collect a bunch of data so that we can put a report together or put a quote together for you. We're going to make the process as easy as possible. You're contracting with your vendor to have NDT work done. We hope to be considered as that vendor, and ultimately we think if we're considered, we will be able to win the bid, quite honestly. We think there's an impartial evaluation will always lead to us. We're very confident in that, and so we stand behind that. That's not meant to sound arrogant. I apologize if it does. We've just got that much confidence in what we're doing here. And so in light of that, we get on site and we start doing the job. All we need from the facility personnel is to know where to park, where to come in for safety, as far as gate access, what safety, if any, what safety classes we've got to go through that day. And then if it is not a full-scale evaluation, if we're going to be coming on the backside of an MI inspection, or if we're going to be coming in as agreed upon ahead of time with the customer to just do what the customer deems as critical assessment areas, we would need the customer to highlight for us the areas that they need to have done. Outside of that, we're going to provide everything else that needs to happen. If it's piping, we're going to use the radiometric profiler. We've already discussed this ad nauseum. We're not going to remove any kind of insulation or jacketing. The customer has no concerns there. When we get into the vessel part of it, the second part of your question, we're going to provide silicone ultrasonic thickness inspection ports. Typically, as Jim was outlining earlier, we've done enough ammonia refrigeration that we know where these things usually are going to deteriorate, and that's typically around the liquid line. And so what will happen is we'll come in and we're going to take between 1 and 3 readings, depending on the size of the vessel and what is required or is deemed necessary based on the condition of the vessel in the first reading. We may take up to 3 readings. We will remove the insulation in those locations. We will install the silicone inspection points. We will use the proper, there's a word for this that's escaping me right now. We'll basically use the proper, what is it, Jim? The gel that we're putting on the end of the UT, I always lose the word there.
Couplant.
Couplant, thank you. We're going to use the proper couplant so that it doesn't freeze, and we're going to be able to take those readings. After we take those readings, we're going to repack a little bit of insulation. We're going to cap that off. There are instances where customers request to have those re-insulated after we take those readings. We do not provide that. We're strictly a non-destructive testing company. We do not provide MI inspection services, nor do we provide any kind of insulation services. We would deem, or we would ask that if you're going to be serious about NDT and you're taking these readings on a regular basis every 5 years or so, it might be wise to leave those inspection ports there. Because now when the next NDT session comes around and we're taking readings, we're able to take them at their most vulnerable spot, which happens to be right there where the last reading was taken. But at the bottom line there, Eileen, the customer doesn't need to provide anything at all unless they want to come behind and provide an insulator to cap off those spots that we take off.
Okay, fantastic. Next, we've got where CUI is on a pressure vessel. Has the CUI been found mainly near the operating liquid level surface areas of the pressure vessel and or nozzle connections?
I think I've addressed that partly, Jim, but I'll turn that to you since Jim, by the way, folks, he reviews every report. He is the last person to see the report before it goes to the customer. So Jim, I'm going to turn that one to you.
Yeah, I appreciate that. No, it depends on the vessel. If it's a ambient temperature vessel and water happened to breach the insulation, then we're going to look at the bottom of that vessel. Whether it's a vertical or horizontal, that's where the water is going to generally collect. However, we also look for evidence of staining. So if a penetration at the top of the vessel shows rusting or caulking failures, we'll look there. But if everything looks good, there's no external evidence of corrosion occurring, and say the vessel is in an engine room, so it's protected from the elements, the first place we're going to go is towards the liquid line.
Fantastic. And I know you guys have answered this question before, but maybe you can remind our audience, what is the largest diameter of pipe insulation RP can measure?
Outer diameter is 24 inches, including pipe, insulation, and jacketing.
Perfect. And does RP satisfy Canadian requirements for internal testing inspection of vessels?
Guys, I'm going to jump right in and tell you I've been doing this for 2 years. And while I think that I can help most customers, there are certain things in any industry that I will not fully learn. So, Jim, I will immediately pass this to you.
Not a problem. No, it will not, because A, it's not an internal inspection, and we don't do internal inspections with ERP equipment. We can go in and do internal inspections as long as there's a manway in some of these vessels, and that's an argument that's been going on. If the vessel is created without a manway or means of entrance, then the only other options you've got are potentially remote visual. So,
Okay. Fantastic. Here's a bit of a vague question, but I'm going to throw it at you guys anyway. Are you able to repair bad piping insulation directly?
No, ma'am, we're not an installation company. I wish that I could answer that and satisfy whoever's asking that question, but one of the things we take very seriously within our organization is integrity. And I tell every customer that I get on the phone with this, if we tell you we're going to do something, we're going to do it. If we've got to deliver bad news or it's something you're not going to want to hear, we're not going to delay that. We're going to let you know right up front what the limitations are. And in the spirit of that, we do not do any kind of insulation repairs or replacement.
Right.
Okay. Here's another question. Is it correct that knowing what your remaining wall thickness by measurement is key and not use or rely on percentage estimates?
I'm gonna address this, and then I'm going to ask Jim to further it out. When we collect the data, we're going to tell you using numerical value how much wall there is. And because pipe manufacturing, don't think ammonia refrigeration, think pipe manufacturing in general. Within the pipe manufacturing world, they are able to produce pipe within a specified value. We often refer to that as a nominal wall value. And pipe manufacturing can be 12.5% less than what the published value says. So we think it's important to give you both of those pieces of data. We're going to tell you the numerical value of the wall thickness as it stands, and we're also going to tell you what the percentage of wall loss is versus nominal pipe. The reason we're doing it versus nominal pipe is that if you don't have non-destructive testing done on your system when it's installed, you really don't know if you're at the published value, if you're 12.5% under the published value, if you're at a value in between those two numbers. So we think it's important to give you the numerical value of the wall thickness as well as the percentage of wall loss versus nominal. Jim, you got anything there?
yeah, one other thing that I'll add is that somebody had mentioned a baseline before, and that's always a good idea. For every given pipe size, the OD, or outside diameter of that pipe, is going to be the same regardless of schedule. And what we're able to do is tell you what the schedule of your pipe is, even if it's the wrong schedule. So unfortunately, we've been in many facilities that the pipe looked great. I mean, insulated, uninsulated, it looked beautiful. It was just the schedule 40 when it should have been schedule 80. So we don't like to say a percentage of wall loss is acceptable either. We want to give you a number, and we can talk to you about that, and it'll change for different companies. But whatever you decide on, you don't want to pick a percentage because of the schedule issue. What you want to do is say there's a minimum wall thickness. It's going to be a decimal point and 3 numbers for a given size of pipe.
Fantastic. You guys are generating a lot of questions. Are you still good to take a few more?
Sure.
Ma'am, as long as you want us.
Perfect. What criteria is used to prioritize pipe integrity?
Folks, I'm going to brag a little bit and tell you that the gentleman that I'm working with who's answering these questions with me he's been involved in pipe-related industries for some 30 years. And he had the pleasure of being involved on the IIAR 6 standards committee when they were developing these standards, and is also involved on the RITA board. So Jim, you didn't think I was going to do that. I didn't really know I was going to do that beforehand, but I want you guys to know his credentials because I'm absolutely going to ask him to talk about this.
Okay. Well, thanks, Eddie. What was the question?
Oh goodness, I got to go back to the archive for that one. What criteria is used to prioritize pipe integrity?
Oh, in general, what happens is different pipes have different service environments. And what we've found over the more than a decade of doing this is there are certain lines that are more susceptible to CUI than others. And more or less in order. Hot gas defrost line, where it downstream of the solenoid valve, where it experiences thermal cycling, is probably one of the worst. Defrost return or defrost condensate lines are usually second. High temperature liquid lines are basically third. And at the bottom of the susceptibility list is suction lines below freezing that literally stay frozen 365 all year.
Okay. Okay. Fantastic. And our next question is, do you supply a preliminary report upon completion of NDT? I think you answered that a bit in your presentation, but could you clarify?
So we don't do a preliminary report where we hand something to you before we walk off the premise. What we do is we're collecting the data every day. And so if we're on a job that's a multi-day job, not all jobs are, but if we're on a multi-day job, then we're analyzing day one's data on day two. And so we're about that kind of delay. So we do that in the event that we've got some clarification or some gap that we need to address. Our technicians are on site and can do that. What we usually do is that we collect all the data, we go through all the analysis, and typically 5 days after being on the facility is when you're going to get that report. And so if we finish a job on a Wednesday, our goal is to try to be able to deliver to you a electronic copy of your report the following Wednesday. And I know you're not asking this, but I'm going to go ahead and tag on to this to say we're real serious about doing report review with our customers. We're not poking a finger at anybody, pointing anybody out, poking a finger in their eye, that kind of thing, by saying, hey, you shouldn't have to draw your own conclusions. Unfortunately, customers come to us sometimes, and that has been their experience in their previous NDT testing environment, where they were given the data and had to draw their own conclusions. So what we do is collect all that data, go through it, and then we reach out to the customer and say, hey, here's a PDF copy of your report. Please let me know when you're going to be available in the next 3 days so that we can schedule a 20 to 30 minute time to get on a screen share. We put Jim on the phone with the customers or somebody from our reporting department, and they go through the report with the customer and give them the high level overview to be able to say, here's your takeaway, here are any kind of critical areas that need to be addressed, and here are things that you should prioritize in maintenance and repairs in the coming days or coming weeks and months. I will tell you, though, that if there's something critical that we find while we're on site, because we're getting real-time results right in the moment, we have had, it's not very common, we have had instances where we've gone back down to the engine room, gone back down to the refrigeration shop and gotten one of the refrigeration technicians or refrigeration manager to come back up and see what we're going through. Jim, you want to explain that a little bit?
I'm sorry, I was distracted here for a little bit. One more time, Eddie. Sorry, buddy.
Explain to them, if you don't mind, what happens if we come across some kind of critical issue going on while we're on site.
Yeah, this has happened a few different times. But for example, if it's a pretty bad ammonia leak, we're going to get away from it, and we're going to go down and tell the owner you have a problem, and make sure that no one else could possibly be affected by that. In other words, keep them off the roof, etc. In other instances, we have run across areas where we just happen to find a very, very low thickness reading on some piping. And in those, we usually put a red flag on those or something and go down and immediately tell the owner, you need to do something with this, and it can't wait. So, yeah, I've got all kinds of stories, and I don't want to bore anybody, so I'm tempering myself right now.
Basically, Eileen, we're not, if there's something critical that needs to be addressed, we're not going to leave the site without the customer knowing about it. But don't get locked into the idea that we're going to sit down and give you some kind of preliminary report, because that's not the best way to handle it. If a mechanical contractor has somebody on site, just like that technician would point something out to one of the maintenance operators, we would do the same thing.
Okay. Well, I've got another question here, and then we can probably move on to the next two. I'm going to interpret this question a little bit because it's a bit confusing to me, but basically it's, I'm reading it like, how often is, like, when you find pitting or corrosion on a pipe, how often after it's remediated or cleaned, does that pipe continue in service, right? So if it's still within the wall thickness that is necessary within regulation, then replacing with new piping. How often do you see that in the field?
I'm going to let Jim address that in just a second, but I do want to say one thing. Like any other type of science, which that's what we're talking about here, and we're talking corrosion, right? We're talking moisture or water being present. We're talking oxidation. There is not a linear equation that says a particular piece of pipe is going to last a specific period of time and then die. I come from a medical background. I apologize up front if this makes people roll their eyes, but it's no different really than being diagnosed with some type of particular illness. Just because you're diagnosed, if two people have it at the same time, they get it at the same time, doesn't mean that the course of the disease is going to be exactly the same for them. Depending on the characteristics, the location where the pipe is on the roof, the location within the country where the facility is, and all these other exterior components, that will accelerate it'll either accelerate the end of, or it'll accelerate the corrosion, or it will extend the life of the pipe. But when we get on site and we identify things for folks, and this is where I'm going to pass it over to Jim, we would tell them, hey, go in and take a look, right? Non-destructive testing is diagnostics, folks. That's really what it is. It's knowing what areas you need to operate on before you go in and start cutting. And so if we identify an area for a customer and say, this is something that needs to be further looked at, the customer goes in, let's say it's wet insulation. They go in, they pull up their wet insulation, they look, the pipe looks like it's in pretty good shape. We've got the right schedule there. We're going to ask them to coat it with some type of corrosion resistant, flexible material. I don't want to mention specific products that are out there, but there are a couple of products in the environment for ammonia refrigeration. We would ask you to coat that, re-insulate it, and that should extend the life of the pipe with an undeterminable amount. Jim, do you have any numeric values you want to put on that?
Well, actually, yeah. I mean, there's been some very, very good evidence that if the pipe is clean and that those products are applied adequately, then you've essentially arrested the corrosion. If water can't get to that pipe surface, the metal surface anymore, it won't corrode anymore. So we have gone back to other places that have remediated their pipe, and there is no more additional corrosion. So they've had a little bit of corrosion. It wasn't a lot. They didn't replace their pipe. They prepared the pipe. They put the coating on. They re-insulated it. And even though they might end up with wet insulation again, the chances are slim, if that coating was applied correctly, that the water actually will get into contact with the metal and corrode it.
Fantastic. I think, well, we're starting to run up against our time here, but let me ask you one more question to kind of segue you guys out. How do you build out scope for your jobs?
So typically we do it as such. We try to leverage every piece of technology that's available. Customers sometimes will ask, can you come out and visit our facility to put a quote together? And we're a little reticent to do that, because if we travel out to do such, then we've got to build that cost and charge the customer for that in some capacity. And there are, quite frankly, better ways to do it. So one of the ways is that we try to gain a scope of work over the phone and using a couple of different questions that we put together. We want to identify the types of equipment, the volume of equipment we've got there. We're not concerned necessarily to manufacture or anything like that, but how many pounds of ammonia, how old's the system, how many evaporators, how many compressors, how many engine rooms, things of that. One of the big drivers, if you guys will recall, if you take nothing else away from this, remember that non-destructive testing primarily is diagnostics, and non-destructive testing secondarily is not a product that you're buying. You're getting a report, which is the result, but really you're buying service. And when we buy service in our personal lives, it's no different than buying it in our professional lives. We're buying time. And so what we're going to do is to try to gain a scope that tells us, number one, is the customer looking to have the entire facility done, or are they looking to have particular areas done? And with that, we're going to build out a quote based on how much time it's going to take. So to gather that scope of work, Eileen, we're going to ask the customer to answer some questions, maybe a dozen or so questions for us, that if they're familiar with their system, they can answer right off the top of their head. There's no additional measurements in going back and walking your system. And then we're going to use a resource similar to, or sometimes using, Google Earth to get some type of satellite imaging. And between those two things, we can put the quote together. I will tell you that we are so serious about ammonia refrigeration that the white-haired gentleman that you guys look at when he gets on the image here, he can, with P&IDs, build out a quote for you. We understand the system that well that we can read your P&IDs just like you do. We'll have some questions about how much pipe is on the roof versus how much horizontal pipe you have suspended in your facility. Not where your drops are coming in, where under your evaporators to cool your rooms, but you have a lot of horizontal pipe that's suspended off the ceiling or in an interstitial space. But if it's a predominantly rooftop system, we're going to look at some Google images. We're going to gather some information from the customer. We're going to ascertain how many days it takes to get that work done, and we're going to give it to you. And one of the things that I will tell you that I'm very proud of Gamma Graphics, again, I'm doing this 2 years with these folks. When we tell you something, they're serious about integrity. If we tell you it's a 2-day job and it ends up being a 3-day job, that's on us. We're going to charge you whatever that quote was for 2 days. Conversely, if we tell you it's going to be a 5-day job and we do it in 4 days, we're going to go back to you and reduce the quote from 5 days to 4 days. The customer only benefits from the way we quote it. They're never going to be put in a position of compromised financial.
Fantastic. All right, any last words, Jim?
No, I'm good. Thank you very much for putting this together.
Fantastic. Yeah, absolutely. And I think that's all we have time for today, but with questions. And on behalf of IIAR, I'd like to thank Gamma Graphics and Eddie and Jim for sharing their time and expertise today. I'd also like to thank everyone in the audience for joining in. And that concludes our session.
Thank you, Eileen.
Thank you.
Thank you. I hope you all have a great day.
Okay, everybody be safe.
Enjoy your weekend.